Augmented matrices. The first step in solving a system of linear equations using matrices is to write the augmented matrix. An augmented matrix has a vertical bar separating the columns of the matrix into two groups. The coefficients of each variable are placed to the left of the vertical line, and the constants are placed to the right. If any variable is missing, its coefficient is 0. Augmented matrices. Here are two examples of augmented matrices. We have a system of equations that is 3x plus y plus 2z equals 31. Second equation, x plus y plus 2z equals 19. And our third equation, x plus 3y plus 2z equals 25. We would take all the coefficients, and this would become the augmented matrix with first row of 3, 1, 2, 31. Again, those are the coefficients and the constants for the first equation. Our second row is 1, 1, 2, 19, which are the coefficients and constant of the second equation. And our third row is 1, 3, 2, 25, which are the coefficients and constant of the third equation. Our second example of an augmented matrix, the system of equations x plus 2y minus 5z equals negative 19, which leads to a first row of our matrix as 1, 2, negative 5, negative 19. Second equation of our system is y plus 2z, or y plus 3z, equals 9, which means we have a second row of 0 because there's a missing x term. 1, 3, 9. And then our final equation in our final row is z equals 4. Because there's a missing x and y term, that would be 0, 0, 1 for the z, and 4. Example, write the system of equations as an augmented matrix. Our system is 40x plus 200y plus 400z equals 660. Second equation is 5x plus 2y plus 4z equals 25. Third equation, 30x plus 10y plus 300z equals 425. Now, because there are three variables and a constant, this is going to have 4 columns in our matrix. And because there are 3 equations, our matrix will have 3 rows. The coefficients of the x term go in the first column, so that will be 40, 5, and 30 respectively. Our second column will be the coefficients of y, so that will be 200, 2, and 10 respectively. The third column will represent the coefficients of the z variable, which are 400, 4, and 300. I will then draw a vertical bar to separate those 3 columns from the constants, which are 660 in the first row of that last column. Second value in that column is 25 from our second equation, and the final value is 425 from the third equation. So we have a 3 by 4 matrix, and I'll read these rows off again. First row is 40, 200, 400, 660. Second column corresponds to the second equation, 5, 2, 4, 25. And the last row corresponding to the third equation, 30, 10, 300, and 425. Now the next thing we're going to do is going to require us to enter this matrix into our calculator. Inserting the matrix into the calculator. To take the matrix we produced in the last example and put that in our calculator, we will first, when we follow these directions, press second, and again I'm on the home screen, so pressing second, then press x to the negative 1. This accesses the matrix menu. Choose this down here, it's underneath math. Right. Press the right arrow twice to select edit. Once I'm under edit, I'm going to select the matrix that I would like to edit. This is most likely 1 for matrix A. I'm going to go ahead and do that in matrix A. Now the matrix we wrote down, our augmented matrix, was a 3-row because it had 3 equations and it had 3 variables and constants. So it was a 3-row, 4-column matrix. So this would be 3, enter, 4, enter. If you notice, the size changes in my TI-84 plus CE to be a 3x4 matrix. Now I'm going to type those values in one at a time. Now it's going to move across the rows, so I'm going to read those values across the rows. So 40, enter, 200, enter, 400, enter, 660, enter. Then it moves me to the next row. So 5, enter, 2, enter, 4, enter, 25, enter. For my third row, I have 30, enter, 10, enter, 300, enter, 425, enter. So what I've entered is the number of rows and columns, and then I typed the elements of my matrix, one row at a time, and finally I will press second and quit to exit to my home screen. Now the next video is going to be about actually doing some calculations with that matrix.